Welcome to the riverbank. Every journey on this map begins at the same starting point, right where our otter is resting, the origin, 0. Every number on this map follows one navigation rule: watch the direction and the size from 0. Let's test that rule by finding the exact location of the integer -4 on our number line. The negative sign gives us our direction. It tells us to move left, away from 0. 1, 2, 3, 4. While the location is labeled -4, the physical distance we traveled is a positive value. This point is exactly 4 units away from 0. A signed number is a two-part instruction. It provides a geographical direction and a measurable distance from our starting point. Sometimes a number lands between the markers. Let's look at how we place -1.5. Just like before, the negative sign tells us to head left from the origin. In this zoomed-in view, we can see why this value doesn't sit between 0 and -1. To get to -1.5, we have to travel 1 full unit to the left and then keep going. That extra 0.5 represents exactly half a unit, so the point lands precisely at the midpoint between -1 and -2. This shows that the number line has a specific home for every value, allowing us to map decimals and fractions just as accurately as we map integers. We can expand this map into 2 dimensions by adding a vertical y-axis that crosses our horizontal x-axis at the origin. Now we can plot an ordered pair. Our goal is to find the location for 3, -2. Take a moment to decide which number tells you the horizontal move and which is the vertical. The first number dictates the horizontal move along the x-axis. Since it's +3, we travel 3 units to the right of 0. The second number is our vertical move. From our current spot, the -2 tells us to move straight down 2 units. We mark the point here in the section of the map called Quadrant 4. An ordered pair is 2 sequential directions, one horizontal and one vertical, that together lock in an exact coordinate on the plane. Looking at the whole riverbank, our negative integer, our decimal, and our ordered pair all fit onto this single, unified map. Each one was located using the same logic. We watched the direction and we watched the size from 0. This rule applies to every rational number you encounter, no matter how it's written. Using this consistent method for every point you plot ensures you can navigate the coordinate plane with precision, whether you're placing a single decimal or mapping out an entire graph.